Picture a planet that looks totally normal from far away until you realize it's basically driving the wrong way down the cosmic highway. While almost every planet in our solar system orbits the Sun in the same direction and spins in the same general way, this one is different. It rotates backwards. Its seasons are bizarre. A day can last longer than a year. And the deeper scientists look, the worse the mystery gets, because the usual explanations don't fully work. So what happened to this planet? And why does it still feel like we're missing the real reason? The planet is Venus. And if you've ever heard Venus described as Earth's twin, that's not wrong, but it's also wildly misleading. Because Earth's twin shouldn't behave like this. Here's the baseline. All 8 major planets orbit the Sun in the same direction, counterclockwise if you're looking down from above the Sun's north pole. That's because they formed from the same rotating disk of gas and dust, same spinning pizza dough, same direction. Most of them also rotate in that same direction. Not Venus. Venus spins the opposite way. That means if you could stand above the planet's north pole, it would rotate clockwise, a motion called retrograde rotation. But the truly brain-bending part is what that does to time on Venus. A Venus day, one full rotation, is about 243 Earth days. A Venus year, one full orbit, is about 225 Earth days. So Venus takes longer to spin once than to go around the Sun. And that backward spin isn't just a fun trivia fact. It's a clue, a fingerprint, evidence that something huge happened to Venus, and we're still not sure what. Let's start with what scientists expected. When a planet forms, it inherits spin from the swirling disk it was born in. That spin direction becomes the default. Now, the early solar system was violent. Stuff slammed into stuff constantly, so it's not shocking for planets to have tilted axes. Uranus is basically rolling on its side, like it got tackled by a moon-sized linebacker. But rotating fully backwards? That's rarer. Because to reverse a planet's spin, you need to either hit it hard enough to flip it, or slow its spin to a crawl, then nudge it into turning the other way. And Venus isn't a small rock. It's almost Earth-sized. Flipping it is like trying to reverse the rotation of a spinning bowling ball by throwing pebbles at it. You'd need something enormous. So naturally, the first big idea was simple. Venus got smashed. A massive impact early in its history could have knocked its rotation backward. It's plausible. It's clean. It fits the vibe of the early solar system. Except, Venus doesn't cooperate with the details. If Venus suffered a single, giant, planet-altering impact, you'd expect other evidence. Maybe a weird internal structure. Maybe a family of moons. Maybe a dramatic scar in its orbital characteristics. Earth's big impact likely created the moon, and you can still see the fingerprints of that event in the Earth-Moon system. Venus? No moons. No obvious leftover debris. No clear smoking gun. And that doesn't kill the impact idea, but it forces a harder question. If Venus was hit hard enough to reverse its spin, why does the rest of Venus look like it's been trying to erase the evidence? Now keep that thought, because Venus is very good at erasing evidence. Venus isn't just hot, it's murderously hot. The surface temperature is around 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is about 92 times Earth's, like being nearly a kilometer underwater. And the clouds aren't water vapor. They're mostly sulfuric acid. If Earth is a documentary about a living planet, Venus is a horror film about one that got away from itself. But here's the key point for this mystery. Venus appears to have undergone planet-wide resurfacing. Large parts of the Venusian surface seem geologically young, as if lava or tectonic activity wiped the slate clean hundreds of millions of years ago. It's like taking a chalkboard full of clues and erasing the entire thing. So, if Venus once had ancient craters, old tectonic patterns, or geological signs pointing to a giant impact, it's possible Venus just deleted them. Which means we may be trying to solve a crime where the suspect set the building on fire afterward. But even if we accept that, another problem remains. A single impact could flip Venus's spin, but could it produce the Venus we see today? Slow, backwards, and weirdly stable? Because Venus's backward spin isn't chaotic, it's consistent. It's been that way long enough for it to be, in a sense, a normal part of the planet. So scientists looked for something slower, something sneakier, something that could act like an invisible hand on Venus for billions of years. Here's where it gets interesting. Venus is close to the Sun, and that matters. Just like the Moon raises tides on Earth's oceans, the Sun's gravity raises tides in Venus itself, tiny bulges in its solid body. Over long time periods, those gravitational tugs can change a planet's rotation. This process is called tidal locking when it goes all the way, like how the Moon always shows us the same face. But Venus isn't tidally locked to the Sun. Instead, the idea is that solar tides could have slowed Venus's rotation dramatically. If Venus started out spinning forward like Earth, tides could break that spin down, 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 until it was almost stopped. And then, here's the trick. If the rotation slows enough, small effects that normally don't matter can start to dominate. Which brings us to Venus's atmosphere. Because Venus doesn't just have an atmosphere, it has a monster atmosphere. The winds on Venus, especially high in the cloud layers, move insanely fast, circling the planet in just a few Earth days, a phenomenon called super-rotation. Imagine Earth's entire atmosphere whipping around the planet at jet speed, non-stop. Now, wind pushing on land is friction. Friction is torque. Torque changes spin. So another major theory is a 1-2 punch. Solar tides slow Venus down, and then atmospheric tides and winds push it into retrograde spin. There's real math behind this. Venus's thick atmosphere absorbs solar energy, heats up unevenly, expands, contracts, creating pressure waves, thermal tides, that can apply torque to the planet's surface. It's like the atmosphere is constantly shoving on the planet. Normally, a planet is too fast spinning to care. But if Venus got slowed enough, those shoves could matter. So we have a new storyline. Venus didn't flip in one dramatic moment. Venus got gradually bullied into spinning backward. But there's a catch. Actually, there are two. First, you need Venus to start with a certain range of initial spins for this to work neatly. Too fast, and the atmospheric torque can't reverse it. Too slow, and tides might lock it differently. Second, the theory depends on long-term stability of Venus's atmospheric behavior, and Venus's climate history might be far messier than we're assuming. In other words, this explanation is promising, but it feels like we're tuning the knobs to get the outcome we want, which forces an uncomfortable thought. Maybe something bigger happened, and this slow torque story is just how Venus ended up staying backward, not how it got backward. So what else could have happened? Let's talk about the elephant that isn't in the room. Venus has no moon. That's not just a fun comparison to Earth. Moons matter because they stabilize a planet's rotation and tilt. Earth's moon acts like a kind of anchor, helping keep our axial tilt from swinging wildly over time. That stability affects climate, seasons, and potentially the long-term evolution of life. Venus has no such stabilizer. So one hypothesis goes like this. Venus may have had a moon, maybe several, formed by impacts early on. And then, over time, gravitational interactions cause that moon to spiral inward and eventually crash into Venus, or get ejected. Now imagine a moon spiraling inward. As it does, it can exchange angular momentum with the planet. It can slow or alter the planet's rotation. If a moon ultimately impacts the planet, that impact can deliver a final torque kick in a particular direction. So the missing moon hypothesis is a hybrid. You can get gradual changes plus a final dramatic event. The problem? We don't have direct evidence of a lost Venusian moon. No easy signature, no obvious leftover debris, and Venus's resurfacing could have erased the best geological clues. So we're stuck again with a repeating pattern. Every explanation feels possible, right up until the evidence gets foggy. And on Venus, everything is foggy, literally and scientifically. But even if we can't see the ancient history, Venus gives us another clue in the present. Because Venus's rotation isn't just backwards, it's strangely synchronized. This part sounds like science fiction, but it's real enough that researchers have studied it seriously. Venus's rotation period is 243 Earth days, and Venus's orbit around the Sun takes 225 Earth days. So far, that's just weird. But now add Earth. There's a repeating rhythm between Earth and Venus called the synodic period, the time it takes for Venus and Earth to return to the same relative positions in the sky. That's about 584 days, and Venus's slow backward rotation has a curious relationship with that cycle. Venus tends to present similar faces toward Earth during close approaches. It's not perfect like a locked mechanism, but it's close enough to make scientists wonder whether gravitational interactions between Earth and Venus could have nudged Venus's spin into a stable state. Now, to be clear, Earth isn't controlling Venus like a puppet, but when a planet's rotation is extremely slow, small torques, tiny persistent nudges, can matter more than you'd think. So Venus might be trapped in a kind of spin-orbit resonance, where its slow retrograde rotation and its orbital dynamics end up in a stable dance. Not because Venus is trying to face Earth, but because physics likes stable patterns. And once Venus fell into one, it stayed there. Which raises the central question again, even more sharply. Okay, fine. Maybe we can explain how Venus's backward spin is maintained. But what started the whole chain of events? What pushed Venus into the slow enough to be hijacked state in the first place? And at this point, we're back to our two big suspects: a catastrophic impact or a long, gradual tidal evolution, possibly involving a lost moon. And neither fully closes the case. So here's the unsettling truth. We have good ideas, but no definitive answer. The most likely story is not a single clean explanation, but a messy combination. Venus may have formed spinning forward like most planets. Then, over time, solar tides slowed it down. Maybe a giant impact, or several medium ones, altered its spin and tilt. Maybe Venus once had a moon that changed the angular momentum game. And once Venus's rotation became slow enough, its thick tidal atmosphere could apply torques that nudged it into a stable, backward spin. In other words, Venus might be backwards not because of one event, but because it went through a sequence of accidents that all happened to stack in the same direction. And the reason we don't know why isn't because scientists aren't smart enough. It's because Venus is the worst possible planet for preserving evidence. Its surface gets rewritten, its atmosphere hides everything, and the key events likely happened billions of years ago when the solar system was a demolition derby. But here's the real payoff. Figuring this out isn't just Venus trivia, because Venus is close enough to be a warning. If Venus, an Earth-sized planet in the inner solar system, can end up with a backward spin, a suffocating atmosphere, and a surface hot enough to melt metal, then the difference between Earth-like and unrecognizable might be thinner than we want to believe. Venus orbits the Sun like the rest of the planets. Same direction, same cosmic flow, but it spins like it's rebelling against its own origin. And somewhere in that backward motion is a missing chapter of solar system history. Impacts we can't see, moons that may have vanished, and forces so slow they only reveal themselves over billions of years. So the next time you hear Earth's twin, remember, twins can grow up in very different ways, and Venus is the twin that won't tell us what happened.